Hey everybody, thanks for joining. Our webinar will start in 1 or 2 minutes. People are just starting to come in now because we've just reached the top of the hour. So thanks for your patience. Again, we'll kick things off in, a minute or two. For everybody who has just joined, thank you for joining. You are in the right place. This is the webinar on doing more with less, how to improve AppSec programs when budgets decrease. So we've just reached the top of the hour. People are still coming in mass. So we're going to wait another 30 or 40 seconds and give more people an opportunity to catch the beginning. So hold tight. We'll start in about 30 seconds or so. All right, I think we're in a good spot. So we'll go ahead and kick things off. So again, thank you for joining. Appreciate your time, whatever time it is where you live. Today's webinar is doing more with less, how to improve AppSec programs when budgets decrease. So we'll go ahead and kick things off. So first and foremost, we've got two speakers today. My name is Orion. I'm VP of Product Marketing here at SciCode. I've got about 15 years of experience in cybersecurity, much of that in application security. Some notable companies include Imperva. I also had a stint in the security operations world. Notable companies there include Exabeam. With me today is my co-speaker, John Jarboe. John, you want to run us through your background?
Sure. Hi, everyone. I'm also, I also have about 15 years of experience in the cybersecurity space. I've been primarily in the AppSec space at a number of the large vendors there, but I've also spent some time in vulnerability management and infrastructure as code security, cloud security, things like that. I have a technical background. I've been in a variety of different roles, from developer to sales engineer on the post-sales side, and obviously in marketing as well.
Cool. Thanks, John. All right, so today we're going to be balancing two competing initiatives. So on one side, we have our application security program and its effectiveness. So, given the threat landscape that exists out there today, what do we actually need to put into place? What should you be thinking about and, actioning upon? On the other side, we have, essentially we're standing at the precipice of a potential downturn in the economic cycle. Lots of organizations are being asked to do more with less, to scale back, whether that's people or budgets, to freeze their budgets, and to look at ways to reevaluate spending. And so those are kind of two competing objectives. So what we'll be doing today essentially is looking at those first separately. So we'll talk about the AppSec challenge. We'll look at, what do we need to do there? Then we'll take a look at kind of the economic side of things and what do we need to do there. Then once we have the pieces together, we're going to build a model that we can use to marry those two subjects and find a path forward. There we'll be looking at some, various different, kind of AppSec budgeting approaches and spending approaches, and to look at the pros and cons given the requirements that we've built up in the first two parts of the presentation. At the very, very end, we will go through a Q&A. So, as I guess a housekeeping item, please feel free to ask questions as they arise. Put them into the webinar console's questions panel. And we will get to them at the end of the presentation. One other Q&A item is that this webinar is being recorded. We will send out the recording within 24 hours. So look for an email if you want to pass it along to colleagues or just reference anything that we've said. So with that said, we'll dive right in. And John, do you want to tell us a little bit about addressing the AppSec challenge?
Sure. Thanks, Orion. Yeah, actually, I guess it might help to explain what we mean by AppSec challenge. The bottom line is that we need to secure our applications, and we're seeing attacks and breaches growing in prevalence, and it's just obvious that our efforts to secure applications haven't been entirely successful. In fact, some might even say that they failed. Part of what we're seeing now is that attackers are specifically focusing on software supply chains, right? They're trying to weaponize software dependencies in order to infect downstream applications and environments. I mean, we saw this with SolarWinds. And these types of attacks, as you can see on the chart, are growing in prevalence, and Gartner expects that they're going to continue to increase, right? Over the next 3 years, they're expected to actually triple. And that means that those of us in the organizations that are creating software need to find ways to successfully secure it. We can go to the next slide there. And that really begs the question, right? What problems does an effective AppSec program need to overcome to solve this problem? To answer that, it helps to consider how it is the case that after 20+ years, we're still struggling to secure our systems. And the short answer is that we're really chasing a moving target, right? Some of the early security programs focused on securing network infrastructure and runtime environments. Essentially, we were trying to protect the data that attackers were after. But as we locked those down, attackers shifted their focus. Instead of trying to reach the data directly through the infrastructure, they started targeting vulnerabilities in applications that could access the runtime and the data. And so we built AppSec tools to find vulnerabilities in the applications. If the apps are secure, then they don't give attackers an opportunity to get into the runtime environment, right? Well, that may be true, but we ran into some hiccups. For one thing, the AppSec tools produce so many findings that we can't possibly fix everything that they report. In fact, there's so much noise that we struggle to even recognize what the real problems are. And that's kind of how we got to this point where we have these AppSec and budgeting challenges. We're just spending so much time trying to stay on top of all the noise that we're getting out of our tools. But there's actually a bigger problem. The attackers aren't the only ones that are changing. You can move forward in the build a little bit there, thanks. Trends like open source adoption and DevOps and the cloud are changing the software development landscape and creating new attack vectors in our development infrastructure, in our pipelines. And these are the attacks that we're seeing today. So securing applications is just one target. We also have to secure the build pipelines and the artifacts and the dependencies and really a whole supply chain which attackers can use to gain access to apps and data. If we can move on to the next slide, cool. And that's a tricky problem because these tools are typically selected, purchased, configured, and maintained by the engineering teams that use them, not by security teams. In fact, security teams often don't even know which tools are being used, much less how they're configured. And that brings us to the first requirement for our AppSec solution. In order to secure the supply chain, we need visibility across all the tools and activity that comprise it. But visibility into the supply chain is not enough, of course. We need to understand all the various types of risks that we face. I'm sure it's no surprise to the audience that the complexity of the supply chain also means that it has a huge attack surface. So huge, in fact, that no single tool is going to be able to secure everything. I mean, you can see all the notes on the slide here indicating the various types of risk. And a lot of those risks break down by phases, where different phases require different approaches. And in fact, there are entire classes of risk that aren't even covered by existing tools. You can see all the notes here that indicate potential weaknesses that attackers could exploit. And at the end of the day, if an attacker can exploit even one of these weaknesses, then they gain a foothold into the development process, into the supply chain, and all of the work we're doing on the DevOps side to build these modern development pipelines and automation within the deployment and delivery processes make it easier for attackers to move either upstream or downstream. And that brings us to our second requirement. To protect against this wide variety of risks, we need a collection of tools that broadly cover the huge attack surface that we're looking at. We already have some of those tools, things like SAST and SCA, container, runtime security. These separate tools look for very specific risks and their visibility is limited essentially to just what they're inspecting. For example, SAST looks for vulnerabilities in the code. It doesn't know how that code is used, what data it's exposed to, or even whether it's running in the production environment. All the tools are effectively operating in a silo because they don't know anything outside their area of expertise. Our existing AppSec programs, which are built on these tools, have demonstrated that using a bunch of disjoint tools leads to overwhelming noise and suboptimal security outcomes. These tools are important, but we struggle to use them. If you could advance the build there. We struggle to use them because we lack the context to understand the bigger picture, right? How do these findings relate to each other? How do they relate to the broader development process? Does code come from trusted developers? Are the vulnerabilities that we find deployed into production? So that's our third requirement. Tool findings need to be correlated with their context in the SDLC so that we can build an understanding of cause and effect across the application lifecycle. That correlation is important for improving security outcomes. If you think about the risks that we face in the real world, right, they're often associated with multiple risk markers at different points in time. For example, a hard-coded secret in source code is a potential risk. I mean, we want to get rid of it, right? We don't want to have that hard-coded secret in there, but there may be more important issues to deal with first. If we know that secret is actually used in runtime and that code has been exposed to untrusted users via a code leak, then we know that this is an urgent risk and it can't wait. Similarly, checking artifact signatures during deployment is important, but how do we know the signature wasn't forged or the signed code wasn't tampered with earlier in development, like we saw with SolarWinds? The correlation information that we build enables us to validate the history of the artifact through container, builds, commits, and ultimately developers. So our fourth requirement is that we gain deep insights into the risks that manifest over multiple related data points. And just tying all of that together, right? To address the AppSec challenge, we need tools that satisfy four requirements. They need to provide visibility across the entire software supply chain. They need to provide good coverage over the vast attack surface. They need to correlate that information so we understand what's happening and its context. And they need to provide deep insights into risks and attack paths that involve observations at multiple points in the SDLC. As we go through this presentation, we're going to evaluate several different approaches based on how well they satisfy these requirements and the budget that they require. And speaking of budget, Orion, I'll hand it back to you to talk about the budget challenge.
Great, thanks, John. So we're going to shift gears a bit. We just got four requirements on the AppSec side. So just, what do we need to build? Now we're going to look at, kind of trends and considerations on the budgetary side. And we're going to pick up three more requirements that we're going to use as we start to evaluate different approaches. So first and foremost, when it comes time to, essentially spend your security priority points, you need to start by understanding your organization very deeply, both in terms of your needs and in terms of your resources. There are several key considerations. These are amongst them. The first one comes down to threats and what is your risk profile or your threat profile. Not all organizations are targeted equally. Some organizations, just based on the value of the data they have, the business model they have, the type of information they have, what type of organization are you, financial services or, maybe a government organization. Not all organizations are targeted the same. And what I mean by that is, there's really two, broad categories of attackers. You've got kind of your persistent nation state type attackers that are targeting, again, organizations that have very valuable or sensitive data. And then you have attackers who are looking to take, an exploit and use it more broadly, like to find a vulnerable dependency that's widely used across the internet, and then to have an exploit that they can reuse, over and over. So you have kind of, highly targeted attacks and attackers versus, those that are doing more of a spray and pray type attack. And so, really coming to grips with what category are you in. Maybe everyone thinks that they're, a high risk, high security environment, but maybe they aren't, right? Think that through. What type of threats are you most likely to face? The next one comes down to architecture. So it's understanding, for your applications and environments, what components do you have, of those components, which of them are, first party, which are third party, which are open source, what components are you sucking in from other places, and in what part of your kind of build process or your pipeline is that happening? The next one, maintenance, comes down to your ability to keep up with the tools that you have in place. So, performing updates, tuning them, onboarding, training your staff, what capacity do you have there? And, how many tools could you essentially do that for? The next one, staffing, very similar, but instead of, kind of the maintenance aspect of it, this is the day-to-day operation of the tool. Can you handle the load from the tool? Can you handle, the triage and the downstream workflows? Can you handle, essentially using all of these tools and running them to their logical conclusion? Now, because we're talking about application security, oftentimes that also impacts developers. Sometimes the actual fix to a specific issue involves touching code, and who's going to do that? Your developers. And so understanding, what are the capacity of your development teams to help with your programs, both in terms of, dealing with fixes, performing research, implementing the tools, performing customization on those tools, really helps you understand, the number of tools and the types of tools that you can use and what your capacities are. And frankly, how much are you taxing your development teams by using specific tools? Lastly, it comes down to capital. Here we're talking about both, financial capital, i.e. budgets, but also, your team and your just general resources. So these are things for you, they're specific to your organization, but they're considerations for you to keep in mind. All right, so now we're going to look at some of the areas for potential savings. So the first one comes down to just basically licensing costs and alignment to your threat profile or your tooling. There's a concept of over and under serving, which is basically having more or less of something in order to do the task at hand. So, having more of it would be over serving, so you have more than you need. Under serving or under delivering means you don't have as much as you probably should have. And in both ways, this really leads to, misallocation of resources. So it could happen that, the cost of a particular tool may exceed the benefit that you get out of that tool. Or conversely, you may be paying a premium for something, either a product or some capabilities that you're not using or you don't need, or you're paying for something that you're not getting. So that would be kind of underserving. In both scenarios, you essentially have a misalignment of your resources that can lead to not being able to cover all the gaps that you need to, or just running out of budget or other misallocation. So I'm gonna give you a couple of examples real quick, but the takeaway here from a requirement that we're gonna use later when we start to compare different approaches is that we need to align our licensing costs to our risk profile in the best way that we can. So licensing costs are gonna be a big factor. So some examples of misalignment, a common one that we see is SAST. So, SAST's job is to find vulnerabilities in custom code. Now, keeping in mind that, 80 to 90% of code nowadays is open source components. So we're actually kind of laser targeted on a smaller, domain within your code base. Here, essentially you need to think back to that, nation state versus spray and pray type attack concept that we talked about earlier. So on one hand, an attacker can choose to pick, kind of an open source component, then find a vulnerability in it, research it, create an exploit, and then look for people who use that vulnerable component. That means that one exploit is, able to be used very, very widely. That's the realm of SCA. But when we talk about SAST, we're really talking about, custom code and finding a vulnerability in the custom code. And that's the sort of thing that often involves reconnaissance, a custom exploit that has one particular reward, that organization that it's written for. Not everybody is targeted all the time by these kind of nation state persistent targeted attacks. Often, most of the time, people are targeted by the other type, the opportunistic automated attacks. And so SAST is not always relevant to the conversation. Moreover, the value of SAST is often kind of relegated to developer negligence and finding things like, OWASP top 10 vulnerabilities, basic injection vulnerabilities. In fact, there's, the 80-20 rule applies very well to SAST, which is to say that 80% of the findings from most SAST tools come down to 20% of the rule sets being triggered. So it's finding the same stuff over and over, and it's often, basic injection vulnerabilities. It's often, developer negligence. It's often OWASP top 10 type threats. So what's the value you're getting out of the tool? Additionally, there are several compliance mandates that require the use of SAST. So, if you're beholden to something like PCI DSS, then you're going to need a SAST tool. So there's absolutely value being delivered there as well. So really, the disconnect here is oftentimes the value that you're getting out of this tool is not necessarily, you don't need the tip of the spear in terms of a SAST tool. You need something that's going to deal with the OWASP top 10 and compliance and help you to fulfill your compliance mandates. And is that worth the percentage of your AppSec budget that most people are spending on it, which tends to be quite high? So there is a possible disconnect there for many organizations. Another example going the other way, kind of underserving or under-delivering, is SCA. Now, SCA is a very important tool. Why? It's important because it's essentially helping you to deal with the open source components that I was just talking about, often which are highly repeatable, opportunistic and automated attacks, right? That affect 80 to 90% of your code base. So this is an important tool. But SCA is marketed as a way to solve software supply chain attacks, or at the very least, a way to manage the risk of vulnerable dependencies. Now, the problem here is that SAST is laser focused on finding known vulnerabilities in application code dependencies. What I mean by that is things like open source libraries and open source components. However, vulnerable dependencies exist in many, many places outside of just code dependencies, outside of just open source libraries. You can have all sorts of other types of dependencies and vulnerable dependencies and all sorts of other things that SAST is not, or that SCA is not looking at. An example, so your dev tools themselves, oftentimes people don't necessarily think of that as a dependency, but it very much can be. So think about your Jenkins, or in the case of SolarWinds, your TeamCity, that can be vulnerable. So you need to know if that has vulnerability in it. Also plugins to those tools. So plugins to things like Jenkins. Just about a month ago, we had a security advisory. There were, I think, 34 vulnerable plugins in the Jenkins marketplace. Also, a very common thing is build modules, things like your GitHub Actions or your GitLab runners. Now, oftentimes those are written by third parties. You can get them out of a marketplace, and they could be written by Red Hat or Twilio or CodeQL. And just like other people writing code, those build modules, those GitHub Actions, often bring in open source libraries and open source components that could be vulnerable. So again, it's another way to suck in a vulnerability. And even infrastructure as code. So your infrastructure as code files themselves can bring in dependencies. And so the point here is that SCA is looking at a much smaller version of the world that could have vulnerable dependencies, which in and of itself is not a bad thing. It just means that you need another tool to deal with the rest of it. In this case, pipeline composition analysis would find vulnerable dependencies in all these other places. But the point is that you've bought a tool, SCA, and it's not doing the whole thing that it's marketed to. You need to go spend budget on something else. So you're essentially getting part of what you need. So just an example of underserving. But ultimately, the problem really comes down to this, which is that a very significant part of AppSec budgets are used to check these two boxes, which is 2 out of 15 of the things that you're going to need to do to kind of secure the overall software supply chain. And so you need a whole bunch of other tools and complementary approaches to deal with that. And many security organizations have so much of their budget concentrated over there in the blue that they're completely neglecting or have big holes over here in the red. And that's ultimately the problem. Okay, so some other areas for potential savings. One comes down to operational efficiencies. And one common place that this happens comes down to kind of the siloing of tools and redundant functionality. It's a little bit like the conversation of a VM versus a container, and how optimized or heavy or lightweight those things are. And what I mean by that is, if you look down here, we've got 2 sets of tools, right? So we've got an SCA tool, you might have a SAST tool, you might have a WAF, it could be a CWPP, it could be a whatever, right? But ultimately that tool, you've got this purpose-built tool. It includes a bunch of enterprise functionality. It needs, integrations to talk to the appropriate systems. You need, configuration and management. You need, some sort of remediation. You need reporting. Maybe it has a compliance dashboard. Guess what? When you use the next tool in the stack, your SAST or whatever it may be, you have integrations with often the same systems. You have configuration and administration. You have remediation, etc. All that same functionality. What that means is that you have a lot of redundancy and overlap. Now, this is a problem really for two reasons. The first reason is that each of those vendors has spent an incredible amount of engineering resources to build out, configuration and integration and reporting. And where they have a cost, then that ultimately gets transferred downstream to customers, being you. The other problem comes down to essentially workflows and workflow inefficiencies. So if you have to, merge the results out of 5 different tools into a single place, or you have to use 5 different workflows, or your compliance has to be pulled from 5 places, or your reporting, it's just naturally less efficient than centralizing all of that into a common platform where you have one set of integration, one set of management, one set of reporting across many different tooling. You'll get some natural efficiencies there. And also because a vendor who is able to do this doesn't have to create this functionality 5 times, and then they don't have to pass the cost along in terms of licensing costs to you. So that's an area for operational efficiencies, and it is another budgetary requirement that we can use to look at our ultimate solutions. So here we're looking for ways to reduce redundancy and complexity across your AppSec program. Another area that's very similar is development costs. So, engineering often has a very strong role in your AppSec tooling. It comes in terms of implementation and customization. More tools means more implementation and more customization. They also have some other areas where they may be impacted. One is in terms of automated processes and being bottlenecked or blocked. So anytime that your developers can't develop, there essentially is an opportunity cost there. You're kind of squandering development resources. And so with all of these different point products in the AppSec world trying to move left, you have lots of stuff that's being inserted into the developers' workflows. And if that all works, great, but you still want a streamlined workflow. And so fewer point products can mean fewer potential bottlenecks and potentially less opportunity cost. Also, in terms of your development resources may be necessary in terms of researching fixes or implementing fixes in the results that come out of these tools, especially where they touch custom code. And so, essentially less tools, you may have less redundancy there. There could be a cost there, and especially in terms of dealing with false positives. So, if you essentially are saying, hey, Mr. Developer, you need to go fix this code because we have a vulnerability that needs to be taken care of, and there isn't a vulnerability there, that's just wasted cycles on your developer. So ultimately, what this all comes down to is less tools often can result in less developer costs, from implementation through triage, through fixing, etc. And so our takeaway here from a budgetary requirement standpoint is, ensure that your security tooling doesn't waste development resources. And so, what is the tax of this specific approach as pertains to our developers? And what this all comes down to is our 3 criteria from the budgetary section are reducing licensing costs, reducing operational costs or inefficiencies, and reducing development costs, or the burden that these tools are placing onto our development team. So as we start to look at those approaches, these are 3 criteria we can use. John, do you want to tell us a little bit about how this all kind of comes together?
Yeah, sure. Thanks, Orion. I guess, we've kind of covered the AppSec and the budget requirements we need to satisfy. So this next section, we're going to talk about how we can find a path forward to implement those and kind of reach that ultimate goal of doing more with less, right? And the first one that we're going to, well, not necessarily the first one. I'm getting ahead of myself, sorry. The way that we're going to try to find that path forward is we're going to explore a few different scenarios about how we can allocate budget and how well they cover some of all of these requirements that we've discussed. For each scenario, we're going to evaluate their ability to satisfy all of those requirements that we talked about. On the AppSec side, we're talking about how well they cover the risks present in the SDLC, how much visibility they give us into the SDLC, how well they correlate the the information about risk and the activity of what's happening in the SDLC to provide that useful context and how well they provide insight into those, complex risks or the real world risks that touch on multiple risk markers throughout the SDLC. Throughout the SDLC. And we're also going to look at the budget requirements, right? What's the cost to acquire the licenses to run these tools? What are the direct and the indirect costs on the team in order to use and maintain the solution? And what's the cost on the development team or for contractors, to select and assemble the tools, glue them into all the processes that your team uses, and that sort of development cost. Looking at the chart on the right-hand side, an ideal score is going to fill the entire chart, right? The chart has been designed so that the more desirable positions are on the outside of the chart and the less desirable positions are on the inside of the chart or toward the center. So the first scenario that we're going to cover is leveraging a collection of established point tools, right? I mean, just as an example, maybe you're using the capabilities of your SCM tool to provide SCA and secrets detection. Maybe you're using a separate SAST tool for identifying those vulnerabilities within the custom code across all the different languages that your application uses. And maybe you have a few other tools that are, looking at like infrastructure as code and runtime and containers. This approach is going to give you pretty good coverage over most of the security risks, although it tends to be focused more on the runtime and the application code as opposed to the software supply chain risks. And it also gives you pretty good visibility across the SDLC because you have a number of different integration points. But all of those tools are expensive to license, and the operational costs are also pretty high. Especially with respect to how the developers need to deal with all of the noise that's coming out of these tools. Probably the biggest problem, though, is that it doesn't cover those supply chain risks, as I mentioned earlier. And as a result, it doesn't really help to address the correlation or the insight requirements. Another problem is that the cost is really high. And so that high cost makes it really hard to find budget that you can use to help cover some of those gaps on the supply chain side. The second scenario that we're going through, is going to focus on open source tooling. So the first scenario, we had really high costs. So what if we focus on this open source tooling as a way to reduce the cost of the licenses? Just as an example, we could leverage tools like Cloud Custodian and SemGrep and Trivy and Dependabot, just a number of different tools to help find risks, right? Those specific tools might focus on the cloud infrastructure and the application code, containers, dependencies, but there are a lot of tools available, and they cover most of the major risks that are present across the supply chain. This approach certainly lowers the licensing costs, right? It's essentially free to get licenses to use these tools. But the trade-off is that you're taking on a really big project. The operational costs are going to be much higher, and you're also going to need access to developers, at least have the ability to pay contractors to kind of tie all of these pieces together, right? With commercial solutions, you'd be able to rely on a vendor who builds everything and establishes all of the workflows and the integrations, and possibly provide some services to help integrate it into your processes. But in this case, you're going to need to do all of that, right? You need to select the tools, you need to develop the integrations, build all of that glue code, and essentially just keep everything running. Even as those individual tools are being updated, you need to make sure that your toolbox is being updated to use the latest, most secure tools. And so essentially you're becoming the vendor, and you're taking on that burden of dealing with the quality of the product that you're building, and the ensuring that your team is able to deal with the quantity of findings that are coming out of it. And so in the end, you really haven't reduced your budget very much. You've certainly reduced the licensing cost, but you've essentially shifted those costs from those licensing, from licensing those tools onto the operational side and the development side of the budget. The third example that we have, well, we saw earlier that using a collection of point products provides pretty good coverage, right? It is expensive, and it doesn't really address much on the correlation or insight requirements. So what if we leverage like a consolidation platform to pull all of these things together? Maybe we can free up some of that budget by streamlining the operational side, correlating the results and maybe standardizing on some of those workflows, as Orion was alluding to. So leveraging a single pane of glass, if you will, we get those same benefits as if we had used the point products, because essentially the point products are still being used kind of under the covers. And we do reduce the operational costs because we're simplifying those integrations, right? We don't have as much redundancy as we did before. And we're also simplifying the workflows because instead of having to deal with individual workflows tailored for each individual point tool, we've consolidated that under a single platform, and that's what establishes the workflows that our security teams and our developers are working with. But one of the things we haven't done is we haven't reduced the licensing costs because we're still using, a number of those tools, and so we have to pay to use those tools. And we've actually increased the development and integration costs because we need to build a more customized platform, right? We're integrating this single platform into our processes, but we also need to integrate all of those point tools into the platform. One of the benefits is that we are improving that correlation and that insight because we do have more visibility across the SDLC. But the information that we're getting through the correlation still lacks a lot of that contextual SDLC data, right? We don't know how our tools are configured, for example. We don't know who our users are and what their permissions are. How those artifacts move through the SDLC, because the information that we're consolidating, that we're aggregating into the platform, is really the output of those AppSec tools. So we get insight into the risks that are present in the development process, but we don't really understand the things that are not being identified by those AppSec tools, such as tool configurations and how things are flowing through the process. So before we get into the fourth one, I just want to talk about a little bit of the difference because it seems similar to that single pane of glass scenario we were just discussing, but there's a different approach that is similar, but where a single pane of glass is really collecting those dots from the AppSec tools, like I was just talking about. What we really need is a solution that also connects those dots along with context from the SDLC. Something that can kind of marry the findings of the AppSec tools, like we were doing with a single pane of glass, with the SDLC context so that we can improve those security outcomes. We're going to call this scenario a next-gen software supply chain security platform. And to facilitate that understanding of the relationships between the findings and the context, it's leveraging a graph database. And what that's doing is consolidating as much information as possible onto a single platform, not just the information about what the AppSec tools are finding, but also all of that contextual information about what's happening within the SDLC. And so this platform is going to correlate all of that information. And it also has the benefit, similar to the single pane of glass, of establishing those consistent integrations and workflows as well. And because it understands the relationships between the events and context, it helps to provide those deep insights that are based on trends across the entire SDLC. So this scenario, if you can advance the slide, Orion, please. This scenario is going to have great coverage of all of our AppSec needs, right? Including the correlation and the insights, And the platform also eliminates the need for a lot of expensive redundant functionality in the various point tools, because you don't need to rely on the capabilities of the point tools in order to get in order to identify all of those AppSec risks across the supply chain. But perhaps more importantly, the correlation and the context that we get out of the platform is going to greatly reduce the maintenance and operational overhead, because we get more accurate and more actionable insights. Essentially, this is breaking down those silos, right, between the different AppSec tools that we had. And that's providing the context that we need to enable those tools to do a better job.
So John, would it be safe to say, if we go back to the connecting the dots versus collecting the dots, would it be safe to say that essentially the value here is not so much just getting data into one place, but it's the insights that are drawn by connecting it? So it takes the value off the scanners and point products and puts it into kind of this downstream analysis and insight world. Is that a safe comment?
Yeah, exactly. I mean, I mentioned earlier, right, a lot of the AppSec tools, one of the big problems that we have with those siloed tools is the amount of noise that they generate, and not being able to identify the real risks from the things that may not be as important. And this being able to correlate that SDLC context into the findings really helps us understand, not only is this a potential vulnerability, but is it, can we correlate that with the fact that it's a potential vulnerability that has been exposed to users, that is deployed into production, and it touches, sensitive data on the tail end. That makes it a much more interesting finding, and so we're able to recognize the things that are more interesting versus less interesting.
Yeah, makes total sense.
Cool. So if we put all of these scenarios together, we can go on to the next slide, please. There we go. We're not going to be able to tell individual customers or organizations which scenario best meets their needs, right? Only they know what their needs are, what constraints they're working with, what their risk profile looks like. But hopefully these charts kind of help you compare and decide amongst the various options. Based on that ideal profile that we discussed earlier and the requirements that we've outlined throughout this presentation, those strong security capabilities and low overall costs really align very well with that next-gen software supply chain security solution. And that would seem to be a great choice to solve those requirements. That combination of great coverage and visibility across the SDLC, plus that correlated context and the insights across the SDLC to develop those kind of multi-point attack paths is really a powerful way to help improve security outcomes while reducing costs.
Wonderful. Thank you, John. So I guess in summary for everybody, what we covered today was, changes in the attack landscape and what you need to deal with. There were 4 conclusions there. So you need, a product that has good coverage of the AppSec points. You need visibility into what's happening across the SDLC. You need to be able to correlate different data points out of those different tools. And you need to be able to have a deep understanding of the risks and the attack paths that you may be facing. On the kind of financial side of things, you need to be able to, essentially align your licensing costs with the threat landscape that you're facing. You need to be able to identify and reduce operational inefficiencies, and then you need to reduce development costs. So hopefully that was useful. And then one real quick slide about SciCode before we go into Q&A. So SciCode is a complete software supply chain security solution. We're built on top of a graph database that can connect and correlate many different types of data, both that from your SDLC and your AppSec tooling. We give you the 8 most important AppSec tools for your software supply chain security solution, all from a single platform. They fall into 2 major buckets, those that help with vulnerability detection. So SAST, Next-Gen SCA, which is pipeline composition analysis, container scanning, and IAC scanning and security. And then on the other side, a whole bucket of tools that help you to harden your pipelines. And so here, it's essentially looking to prevent breaches and to prevent code leaks and keep attackers out of your pipeline. Here we have security and governance, looking for security controls, implementing consistent security controls, finding misconfigurations, hardening your pipelines. We got code tampering detection, hard-coded secret detection, and code leakage detection. So that's kind of it in a nutshell. With that said, we're going to shift gears and give people an opportunity to ask questions. So if you have questions, please feel free to use the questions tab in the webinar console, and we will start answering them. In the meantime, I see that some have already come in, so we'll just start kicking things off. Okay, John, this one's probably for you. Why doesn't a collection of best of class tools or a single pane of glass using those tools score higher on insight or correlation? And I guess I can go back 2 slides and illustrate what they're talking about. So a single pane of glass here and collection of point tools, why aren't they higher on these 2, insight and correlation?
Oh yeah, I mean, it's a good question. So for the most part, it's really about that SDLC context, right? I mean, both of those approaches are leveraging the AppSec tools to identify the security risks, but they're not including the general context of those findings in the SDLC. So they don't consider information outside the realm of those specific tools, right? I mean, the example I think I provided earlier was with SAST. SAST knows the code and it can help you find vulnerabilities within that code, but it can't tell you if that code is deployed, and it can't tell you if that, if the potential vulnerability is a SQL injection. It can't tell you what type of data that application is handling in runtime. And so without that information and that context, it's really hard to understand what the real business priority for that particular vulnerability is. It makes it really hard to prioritize the findings, and in a lot of cases, it just makes it hard to even know if you need to worry about that finding. If it's a SQL injection and the application doesn't actually work with a SQL database, then it doesn't really matter, right? Because you're never going to be able to exploit that because the application isn't working with SQL commands. So that contextual information is essentially what hampers the usability of the AppSec findings, or rather the lack of that contextual information is what hampers the usability. And since those solutions lack the ability to fill in those gaps, they can't really score much higher on correlation or insight because they just don't have the information to correlate and the insights to deliver.
Awesome. Thank you, John. So I'm going to go back to our Q&A slide, and then, okay, we've got some more coming in. Okay, you mentioned pipeline composition analysis. What is that? Okay, so I guess I'll take that one because I mentioned it. It's basically the same idea as software composition analysis. It's just, if you had full visibility of everything in the pipeline from code to cloud, and you took the same concepts as SCA, but with that new vantage point and new visibility, what would SCA look like with a broader scope? And it can essentially do a bunch of cool things. It can find dependencies, vulnerable dependencies in places that SCA can't look today, but also it can do other things like understand, SCA would be able to tell you, like if you got log4j, what repo is it in, what component, etc. But it wouldn't be able to tell you where that got deployed into production, like what Kubernetes pod actually has log4j in it. And so, pipeline composition analysis, by connecting everything end to end and having full visibility, can start to answer those questions. You have log4j in your code here, and you have it, deployed into these Kubernetes pods, and to clean the whole thing up, you got to deal with it on both ends. So, think SCA, but zoom out and look at the whole pipeline, and that is pipeline composition analysis. So it's a new thing. You're going to start to hear about it from a bunch of vendors, but it's kind of the next iteration or the next generation of SCA. Okay, another one, and maybe John and I both probably have an opinion on this. Can't I just put all of this data into my SIM and get to the same place as a next gen platform? I'll take a stab at it. I came from the SIM world. John, I'd love to get your take on it too, but I mean, essentially no, right? Like SIMs there's a couple of reasons that are preventing this. So first off, a SIM's job is to, for the most part, collect logs. Not all of the information that is needed to do what we're talking about here, especially that about the environment of the SDLC. What are the security posture? What is the settings of these tools? What's the environmental state of your tooling? That stuff doesn't exist as in a log format, right? It's just contextual information, and so that would all be missing. But then secondly, you could get a single pane of glass from some of the data from your AppSec tools, but you'd be kind of missing the ability to connect those tools in a meaningful way that includes the context I just talked about. And if you were to build that on top of a SIM, you'd basically be building a completely different product. I mean, you would be turning into a software supply chain security vendor. And there, I mean, you'd have to, really invest an awful lot to build a graph database and, to integrate with all these, dozens of systems and really to learn to connect that data in a meaningful way. SIMs are just not built to do that. Also, it'd be really expensive. So I don't know, John, if there's anything that.
Yeah, I mean, yeah, everything you said, but I think the real key is that you're lacking that contextual information, right? I mean, SIMs are consolidating information from various data sources, and you just don't have things that are logging that SDLC context, and that makes it impossible to correlate the AppSec findings with the context and then to develop those deep insights.
Yeah,
and I guess that just ignores the whole side of once you have the that correlated information, you would need to build a bunch of custom queries to look for the risks that that look for the attack paths and the indicators of risk that would point to the problems that you need to worry about.
Yeah, I mean, in a nutshell, it in theory might be doable, but again, you'd be building kind of a net new product, and it would be like the complete opposite of doing more with less.
Yeah.
Yep.
Yeah. Would it even be called a SIM at that point, right?
Absolutely. Okay, so here's another one. Interesting. Recent history has shown, and software breach has shown data, and software breaches result in upper management of firms becoming unemployed, in parentheses, getting fired. Where is the cost pushback originating from in a firm when it applies to security systems? Do you want me to read that again?
Yeah, I did.
Yeah, okay. Basically, so when a software breach happens, upper management gets fired. Where is the cost pushback coming from in a firm as it applies to security? Is it in a nutshell? So I guess the question is like, if everyone's going to get fired, if there's a software breach, why are they cutting budgets?
That's a good question. I mean, I imagine that the answer is different for every organization, but in my experience, one of the issues I think is that it's just so hard to justify the expense of security, because it can be very expensive upfront, right? It's a lot easier to justify after you've been breached, because those of us in the security world, we understand the risk that we're facing and the likelihood of a breach. But in the boardroom, I think they're a lot more disconnected. They don't realize just how real of a threat it is. And so it's hard to say, look, we need $1 million to go secure our software. It seems like a lot of money. And it's hard to say that by spending this $1 million, you're going to prevent this particular problem for sure, because you don't really know if that problem is going to happen or when it's going to happen. You know that it will eventually, but you don't know if it's going to happen this year or next year. And that makes it really hard to make a justification when you're requesting the budget, I think.
Yeah, I mean, that's kind of like the insurance argument, right?
Yeah.
You don't know if you're ever going to need, am I ever going to have a claim on this insurance policy? I guess the other thing I will add to that is no departments at any companies have, blank checks. Security is no different. And so, essentially what I think the crux of the issue right now is that a lot of companies are looking at a potential downturn and, in the economy, and they can't just, write blank checks if they're worried about, like, hey, what if, the economy turns and that affects our customers and that affects us. Like, we can't just write blank checks, I think ultimately is what it comes down to.
Yep.
Okay, so another one. Okay, how can your solution provide so much better security at a lower cost? I guess the idea, so they're connecting the dots between the last two slides there, which is basically that, like, there's a next-gen platform and we are the next-gen platform. So, how are we able to do so much and still save money? Is essentially the crux of that question, I think.
Yeah, and I think the key really comes down to that context, right? Being able to take AppSec findings and risks and put them in context really helps you to understand how they relate to each other, right? Which ones are more important than others, which one are more immediate than others. Just building those connections and understanding which ones are more important is huge for helping teams accomplish more with less, because they have a limited time budget in particular. So if they only have so much time to work on fixing some of these problems, if they can focus on the ones that are most important and most immediate, then they're going to get more done. And that kind of, I guess, filters through the process, right? It's not just a matter of you're doing a better job of connecting the dots, but because you're breaking down those silos, because you're enabling your team to understand which vulnerabilities are exposed to users, are deployed into production, and kind of building that correlation and that history really helps to accomplish more. So you don't need to have all the fancy bells and whistles necessarily in the scanners, like you said before, right? This next gen platform is really taking the emphasis away from the scanners. You don't need all the fancy technology there to try to get around those limitations of working within a silo. You can kind of take that back to the platform level and make much better sense of the information that you're getting out of those scanners. So the scanners don't need to do as good a job, because they can identify a lot of issues, and then you can rely on the context and the broader platform to make more sense of that and help you understand which ones represent the real risks.
Yeah, and I would add to that, like, basically more data improves that story, right? Like, more data gives you better results. And so as you add more AppSec tooling, as you add more information about the SDLC, then the results of all of those things get better. It's, kind of a synergistic approach.
Yeah, that's true. And that's almost the opposite of traditional AppSec, right? With traditional AppSec, well, at least in a lot of the organizations I've worked with, they want to try to tone down the amount of information that they're getting, because all of that information needs to be interpreted by humans. It's a lot of manual effort to make sense of it. And with a platform like this that leverages a graph database to understand all of those relationships, you can offload that to the platform rather than requiring people to do all that work.
Absolutely. Well, I want to thank everybody, so that we are basically at the top of the hour. So just some quick housekeeping. So first off, thank you everyone for joining. John, thank you, for presenting and all the knowledge you shared with everybody. And then, from a housekeeping standpoint, if we didn't get a chance to answer your question, we will try to get back to you via email. And then this was a recorded webinar, so it will be posted within the next 24 hours, and you should get a copy via email. So thank you everyone for your time. And John, again, thank you.
Yeah, thanks everyone.